So, so quick introduction before even I begin talk about Databricks in general. I want to touch base upon the very concept why Databricks or likes of these products like your Snowflake in Amazon ecosystem, they have their own data pipeline platform. So what is it all about? So it's all about I would call it a classic data engineering pipeline, which is more or less most organization uses. Whether you use AI or you do not use AI, you will need this data engineering pipeline. Pretty much every organization, government, banks, everybody uses it. So what it does, essentially what it entails, and of course, this data engineering pipeline goes to into specificity, example using a Mendelian data architecture or some other kind of data architecture. But in nutshell, what it is, essentially, you have variety of data sources for any organization. Even when I'm operating my really small company, I have, believe me, 5 or maybe more than 10 data sources. Example, if I'm hosting this meetup, I'm hosting on multiple sources, multiple platforms, and from there, the sign up is coming in. And if I were to analyze the details of it, I might have to create a data engineering pipeline. Believe me or not, for a really small company like me, but I'm not doing that because I don't have time. But in a larger organization, say bank, insurance company, government, they usually have multiple ways of interacting with either customer or data. So in this example, what I've shown is that top one on the left side is a say database, images, IoT, video, CSV, and documentation. All these files, they actually need to come to certain kind of a data reservoir. And the process of bringing the data into some kind of system is called data ingestion. And here is the one of the big difference between how you do data ingestion in a data lake or a lake house architecture versus data warehousing architecture. Data warehousing architecture is essentially what you mean is that a SQL based data structure where you know the schema of the data before you ingest. That is called schema-on-write. In that category, you can count all the relational database, large warehouses. They have been there for, I would say, multi decades now, and they are still critical part of the system and will remain. So the only challenge with that type of data system is that you need to curate the data before it goes in, because if you have a JSON video or anything like that, it's not going to ingest properly, because in all these warehousing based systems, specifically the traditional system, the query engine and the data engine both are the same. Take an example, Oracle. Oracle, once you get the Oracle database or anything, it is the same thing. You ingest through Oracle API or SQL instruction and data goes. And that poses a lot of challenge in many cases. They call it a schema on read. So usually data ingestion is not really fast. On the other hand, when you're talking about data lake or lake house architecture, what they talk about is called schema on read, not schema on write. It means they will let the data to ingest as is without doing any kind of a tweak transformation. You just dump the data. Dump the data. Once the data is in, then you use variety of method to either query the data or enrich the data or refine the data. In many cases, you don't even need to do anything. You can directly query the data from the raw format itself. Example, you ingest bunch of data into S3, and you can use different types of query engines that are available to actually get the data out of it. So that is your classic style of a data warehousing, data lake. And of course, as you progress through it, you do a data processing, you do a batch processing, stream processing, and once you have curated the data and all this good, then your data is ready for use, which is your machine learning, data analytics, LLM, you name it. So that is a kind of a lay of the land. And where all these platform lies, your Snowflake, Databricks, Hadoop, Big Data, Data Cloud, or you can talk about Amazon and Azure, GCP, BigQuery, they all play a certain part of the role. But surprisingly, you will see not a single product out there which actually does everything. In this, the diagram I put it here, it probably entails maybe 20 or 30 tools you can check with anybody who's working on the industry, they usually touch 5, 6 minimum tools to actually touch different part of the data. So the whole ecosystem right now is driving towards a kind of a paradigm where they are able to use less amount of data. So example, if is it possible the data I'm using for ingestion, can I use for data curation as well? Can I use the data for processing as well? So when that question arises, this is where your a Databricks based offering comes in. And again, other tools are also available. I'm not saying Databricks is the only way to do it. There are multiple ways. So the key benefit of Databricks is it's built on Apache Spark, and Apache Spark is, I would say, even is popular among many developers. But again, it is not really simple to use, because if you want to operate a Apache Spark cluster, it is a pretty much full-time job. You need a lot of engineers and all those things. And it actually supports data engineers, analytics, and now with AI. Provides collaborative and scalable environment, a data set, and integrate with cloud ecosystem. So usually whenever you are doing Databricks, you're always talking in a context of a cloud. It is similar to, you can think of a Snowflake. You deploy the Snowflake on Amazon or Azure or GCP. Similarly, when you do Databricks, you actually attach with a certain specific cloud. In this example, I'll be using Azure Databricks. The reason is simple, because the way Databricks has integrated with Azure, it has become a native Azure service. It is not like a marketplace or a third-party service where you have to create complicated rules here and there. Benefit of Azure Databricks is that once you can simply use Azure APIs, as simple as that. And what it does, it makes your all those deployment pipelines super easy. You don't have to do none of that. So example, so a lot of time, like why Databricks? So Databricks is, if you see, Databricks started as a data engineering platform. It never started as a data warehousing product. It was always, if you see, it was developer driven. When I first time used Databricks, maybe 2018 or sometime, I knew it as Apache Spark. You just go and do a Spark job here and there and you are done. And over the year, they have slowly introduced more and more feature over towards data warehousing side. And in many cases, they're directly now competing against Snowflake. So Snowflake, coming from a background of a data from a data warehousing ecosystem. So they started from the other side of the spectrum, and now they're adding more and more feature for data engineers. Like they're adding a lot of features. You can actually run Python jobs, you can run ML jobs, you can run AI jobs, pretty much everything. So they are basically, they are coming from two sides of the equation. But most organization, what you will see, I would say maybe past 5 to 6 years, they have evolved to be a shop where they use Databricks and Snowflake at the same time. So they use Databricks for their a lot of ETL jobs, or maybe they can run a lot of automation, coding, and they use data Snowflake as a kind of a solution where they are using data warehousing. And with the advent of Apache Iceberg table, now people are talking about just keep the data in one place. So example, you keep the data on S3 bucket, create them as a Apache Iceberg table, and allow Databricks as well as Snowflake to access the same data, doing a zero copy architecture. And that is a really great solution for engineers and for enterprise as well, because now you can use RBAC of either of these tools, both popular tools, and leveraging the same data and doing a lot of work. So it actually helps to reduce cost and at the same time accelerate your development. I think I will mute Sayed. Okay, so Databricks architecture. This is directly taken from the website. So I will just directly go to the website. There's no point doing it here. So before you even, I think someone mentioned you guys want starting with Databricks. So before you even begin, you need to get a little bit understanding about how Databricks. See, how Apache Spark works is very different from how Databricks is actually designed the solution for their end customer. Because at the end of the day, they need to make sure that customers are able to use the product, they're able to bill it correctly, and at the same time keep the cost low and the security. From that standpoint, so how they usually operate, they call something called a control plane. The control plane concept is very common in all cloud native architecture, including Kubernetes and Snowflake everywhere. They have a certain kind of a control plane where they are running their internal software applications, which I will call very Databricks specific. Just to operate the cluster, they need certain components. So they call it a control plane, and control plane runs on their account. So whenever you spin up a Databricks account, it's basically you don't spin up actually control plane. All the time, whenever you're spinning up, you are spinning up this part of it, which is your workspace. So control plane is already there, is running, always running on Azure or Amazon. When you use either a click-based approach like a GUI or use a Terraform, you're essentially firing up your those control plane APIs. In this case, in Azure case, you're directly firing the Azure APIs and it just creates the system in background like a magic. And what happens, you creating a workspace. And of course, these scripts, you can actually take it further. You can do completely your Unity catalog setup and everything. So that is the, I would say, the structure of it, and the few key feature of Databricks, what it brings it specifically with their Delta Lake architecture and protocol is they are supporting asset compliancy. It means whenever you are putting a data into Databricks, their their Delta Lake, these are all asset compliant, mean they are as good as SQL database. Whenever you write the data is consistent and it is immediately right. It is not eventually right solution, as opposed to if you are doing any NoSQL database. Say example, you are using say DynamoDB or any kind of NoSQL database. They most of them are eventually right. It means when you write a call, API returns, and when you get the return of the API, you are not actually you're not sure that the data has been replicated across all the nodes. But in this case, it does. And same thing applies to your Apache Iceberg. It ensures that Iceberg tables, they are all ACID compliant. That is why it has become really a go-to solution in the market where people are using everywhere Iceberg table because it is an open format. So whether once you have data in Iceberg, you can actually read from Snowflake, you can read from Databricks, and also you can read from AWS native services. So these are the some of the concepts here, and that is the I talked about Medallion architecture, which is your different way of how data pass through different cycles. So having said that, we can go to the next section unless you guys have any specific question. So we'll quickly do a case study here. Case study is basically to highlight the fact that I think anybody can do it. It's a very simple case study where so we have a product, is called, it does a forecasting. It's basically a machine learning product. And what it does, it runs on a heavy machine, on a virtual machine, which if you have a virtual machine with 100 GB or more, you will be paying at least $1,000 a month. But what we did was, instead doing that, we basically converted the whole Python machine learning application into into no, your serverless jobs into Azure Databricks. And what it brought, the cost collapsed completely. Instead of paying almost $1,000 for VM, because all these are bad jobs, they run once in a week, once in a month. And if you're using a serverless compute where it comes up and runs the model and spit out the result and goes back to sleep, you're not paying any of the cost. So in these cases, serverless compute, if you're talking about, you're talking about at least 90% of saving in terms of cost and real green dollar. So that I will send a link later. You guys can take a look. If anybody is interested to learn more about it, you can reach out. And next thing I will talk about what we are going to do in today's demo. So today demo, what we will do is we have a Git repository where I have a bunch of Python code, bunch of Terraform code, and then these are all running on, say, you can either fire through GitHub Action or you can fire through your laptop as well. And what we'll do is these are all Terraform code. They will fire the Azure using Azure RM, and it will spin up a Databricks workspace. It'll spin up a quick Databricks workspace, and then in the workspace, it'll deploy a Python notebook, and you can deploy a ML job also with cron. Cron in the sense that if you want to schedule every night, every second day, so all these things could be done. So that is the basically part of it. And of course, I need to set up my. So this demo has actually two parts, and that is how you actually do most cases when you are doing a Terraform setup. So one part is your infrastructure setup, where it's actually setting up the workspace, which is the infrastructure. And the second part is the application, where it is deploying those Python apps. So they have segregated into different folders. So assume not everybody has a Azure account, right? Not everybody can spin up this thing. If you do not have that option, what you can do is you can go to Azure Databricks and sign up for the free account. And once you have signed up the free account, you can create a token over there and use the application side of it and to spin up this part of it. So there are two part of it, right? So, so any question on this particular demo before I actually start doing the work? Of course, I'm trying this demo almost for after 2 months, maybe 1 month. So a lot of stuff may not work. So I will be doing troubleshooting, and please feel to ask anything. Yeah, Hassan, go ahead.
Hi.
This is the free one. This is absolutely free. See, I spin up using my Gmail account, and it did not ask any password or anything. So I have everything. So they come up with a bunch of, see, this is my Python code. This is so example, simple Spark code you want to run, load simple file. A lot of experimentation you can do with this free one. So free account, if you want to do it, go to databricks.com and just sign up with your Gmail. No credit card, nothing is needed. Just boom, you are inside. And that gives you a kind of a starting ground, because if assume I think someone mentioned, I think Mary mentioned that, hey, I'm spinning up, we are moving to Databricks. So if you don't have access, whatever it is, this is your playground. Get familiarized with it, and then but a lot of feature will not work here, and those are, I would say, the complicated part of the game is the setting up the external data and loading data here and there. Those are only available in the premium section. And if I go to my Git repo, yeah, where is my Git repo? Oh, here's my Git repo. So this is the Git repository. So as I mentioned here, I have two sections. I have this apps. So in the app, I have created, say, dev and modules. So example, if I go to dev, I have main.tf. It tells me the job. So what I'm doing here is that two section, the way I have segregated, one I call infra, one I call apps. So in the infra, I will be deploying the Azure, the infrastructure part of it, which is your workspace. So example, if you have a Azure account, then you should use this one. So if I go here, let me open my VS Code. So example, yeah, actually I don't use this Windows laptop, but usually I have seen the Azure product works better with Windows than Mac. So, so example, this one you can see here, I have the infra section. So infra, what I did, I have divided into prod, and in production, what I call as a US East and West. So assume, so if you go back to this diagram, so here I have put a bunch of diagram also for clarity. So assume if you want to assume your job is to deploy Databricks, and someone say, hey, can you give me a DR strategy as well, BCP, which is called business continuity plan. So in that case, what you can do is you can leverage some part of it used to deploy two sides. So there are many types of DR activity happens. Again, DR activity by itself, it is a continuous process. There is no magic that you press a button and become DR. So DR strategy, you need to work with your engineering team to make sure it's like a active, passive, or you're talking about pilot, light pilot, whatever strategy you are thinking of. But this Terraform based CI/CD works really well. So example, you use this Terraform based solution, and each time you're doing any update you do on the Terraform itself, do not do anything on the GUI. So what it allows you is that whatever thing you are deploying here on the primary, you can always apply on secondary. So that gives you ability to instantaneously bring up the other side if something goes wrong. As far as the user and Unity catalog goes, you can actually have a centralized authentication. Example, you can use Azure AD. And as far as the Unity catalog related some stuff goes, you have to use combination of script and Terraform to basically sync the authentic those items. Those are very specific example. You are setting up in Unity catalog a external storage. So those kind of information you have to sync it. And as far as the data is concerned, so data concerned, actually, you can apply two-way strategy. One, you can simply use the cross-region replication feature of the cloud provider itself. In Amazon, you are using a cross-region application, and in Azure, it is called GRS. Or you can use Databricks deep clone method. What it does, it allows you to copy and as well as help you to do time travel as well. So these are the many options are available. You have to play around with it, experiment it before it works. Yes, DR is a disaster recovery. So example, if you want to do a DevOps automation of a multi-region DR activity, so what you're talking about here is you have a bunch of configuration. So anytime you're designing a good DR activity, first thing you need to do is make sure you're not using any of the click ops. Do not do any click-based operation. As far as possible, avoid it on the console. The problem with that approach is that whatever you do the click, it is in your brain, in your memory. You do not know how many click you did, and you have changed certain configuration. There's no way to replicate it. And whole idea of infrastructure as code is that you do everything through code, and whatever you are doing, it is timestamp snapshot into Git repository. And if you did a mistake, which is will do all the time, that is part of the job, but you should be able to identify the mistake and make a corrective measure rather than just looking out what I did mistake. So these things, code you put on the Git repo and you manage everything through, say, either GitHub. In this case, we'll be doing a GitHub. You can use ADO as well, and package, of course, you use some other tools like Artifactory, Azure Container Registry, or Nessus. And then you have your CI/CD based automation to basically replicate across these two things. So as I mentioned, in this particular one, you have it will do these things. So when you deploy Azure Databricks, there are two ways out of the box they give you. One, they call it a simple approach, and another one they call it a VNet injection. And in most cases, I will not say most, I will say all the enterprise cases, they will prefer VNet injection because you are able to control the network access of the Databricks resources, and you are able to peer your VNet with other services as you may need. Because often the case, Databricks, whenever it is running, it is not running by itself. It has to interact with other applications, other data sources. So you need to have that flexibility of networking so that you can poke a hole in the firewall, create different VNet, so that you can hop across different segment of the network in your enterprise ecosystem so that you can do the job. So that will be one. Second, requirement wise, you need to, of course, you need to have Terraform, you need to have AZCLI, and you have to ensure you set the right subscription. And these are the command pretty much, I think, and I usually, I mean, if you see when did I change this file, I changed 3 weeks ago. So probably 3 weeks ago it worked, and I have to try if it works or not today. An example, I can go to say example here, and I can do on WSL. Windows also you can do. Simply you do let me see if I have a Terraform here. Yeah, I have Terraform here. So I do export. And to test exactly if my things are working, I will go ahead and delete all these code here. So you can see I already have a job and pipeline installed. I can just simply delete this one so that my workspace, everything is clean. And here is a shared, this one I can delete. I'm basically deleting whatever I created. And now I put my PAT, which is personal access token. Second, I need to put this URL. So if I go here, and I put this. And now I simply go to the folder. Where is my folder? Maybe I'll just clone a new repository into Linux. I can use HTTP also because it is public open. And then I just simply follow the instruction here. Because I'm not doing the Azure resource, so I don't need to create any Azure stuff. I can simply do here, deploy the job and code. So I can simply go to apps, dev, and do Terraform init. I have to install Terraform. Usually even exe file also works here. Good thing about WSL is that you can run exe file also on Linux. That is the magic of WSL. So see, when I did the init, it actually downloaded all the necessary package needed. And then I do Terraform, say plan. Okay, I cannot find. I need to create a file here, TFR. So I can create a VS code here also. Okay, state file is locked. So you can see it shows it will be able to deploy this on this particular thing. And just to give you a little bit background, if people are getting lost. So why am I exporting those variables? So in this Terraform module, by default, if you export this environment variable, you do not have to hard code the host name and the access token. So it is a best security practice. Even if you go to my this GitHub notebook job YAML, see what am I doing here? in this notebook job YAML, I'm just putting the secret and it will just simply deploy it. So there are two options. One, actually you can use this one, like as how I'm doing on the Linux command prompt. Another option, I can straight away go to my GitHub and do the deployment, this particular GitHub action. So for that GitHub action to work, what you have to do is you have to go to your this one, secret and variable, and click on action. And here you have to update these two. So example, if I go to Databricks host and I put this host what I just got here, this one, this is my host. And then next is the token. So token, I will go ahead and update, which I just got it. And of course, I'm right now I'm sharing the token, but once the demo is over, I'll go ahead and delete the token. So just to make sure that if anybody has recording, they shouldn't be able to access my own token. So once I am done this, I can simply go here and do an action and fire the action here. So example, I have called deploy Databricks job, and I can simply do the main branch right now in the main branch and run a workflow. So just to verify that my jobs are not here, very simple way, you can go here, check the jobs. I see there is no job here, and after deployment, I should be able to see the job if it runs successfully, of course. So see the job, I can see the status of the job and see it is doing Terraform init. It is doing, looks like it is okay. And job is completed. So if I go to see, it just appeared here. So this is scheduled. And if I go to my workspace and I can see my code is also here. Where is the code? It should be somewhere here. Code should be here. These are older repos. Yeah, this is here. Code is here. So this is the nightly job I was running, and this is a simple, very simple Spark job. What I'm doing, I'm opening this particular folder and just doing some simple calculation, generating an alert. So that is basically, I would say, this is what we did. What we did, just quick recap. So what we did was we took the code, Terraform and Python code sitting on GitHub repository, use GitHub action to trigger a automated job, and you can choose Azure, and you can simply bypass Azure. You can directly go to Databricks. Remember, whenever you are creating the infrastructure, you are directly interacting with Azure and Amazon APIs. But once Databricks has been deployed, the workspace, then you have to fire directly endpoint of the Databricks itself, not the Azure. So that is how you will do. And now it depends upon your job role, right? Assume you are a platform engineer, then of course, most of the time you will be actually firing the APIs to Azure, not necessarily to this side. But on the other side, say if you are in a part of the application team, you are just building a CI/CD pipeline for that. In that particular case, you might be just doing, you might be firing up those workflow jobs. You'll be working with data engineers to make sure their code is up to date on the Git repo and they are working through the pipeline. So that will be, I will say that will be the typical use case that you will be mostly dealing with anyone. Any question, or should we use the same token? No, no, don't use my token. Use your token. So that is any other question. So anybody has, so I can talk about that. So we also have a program called DevOps Launchpad, where what we do is we basically partner with local employers in Toronto area, where we provide training to the people and then place them into the organization. So we usually work with the organization to fine tune the requirement for their example. Some company might be running a completely Amazon stack, and they may not have, say, Databricks. They may be have Snowflake, they may have Kubernetes. What we do, we work with their hiring manager and create a custom training plan. So say only targeted toward Kubernetes and AWS. And we create a 5 or 6 weeks of intense training program for, say, what we do, we hire people from from Toronto, local people, and then basically train them into that particular technology and then place to the employer. What it does, it brings value on the both sides. First of all, employer is getting a benefit of, they're getting a pre-trained people on that particular job role. They don't have to train for that thing because the person who is coming on board is most likely to be successful. Second thing, also it addresses the skill gap. So a lot of people, they may not have the right skill that companies are looking for, and many times these skills are actually chicken and egg problem. So if you don't have, you need experience to gain experience. So it solves that problem as well. And it works out really well for the both side. So if anybody, so again, we have both programs. We do a retail program as well, where we train individuals, just teaching them DevOps in a particular area without attached with the employer, so that you get a training, you can get any job. But if it is a attached with the employer, in that case, you usually place to that particular employer. So if anybody interested, they can reach out to me for that thing. Otherwise, I don't have anything else other than, you guys have any specific question